Hey, my name is Rafi. Let's talk about hydrogen for automobile. Fossil fuel, while being one of the most important commodities in the world, is lacking in terms of supply, resources, and environmental emission compared to its renewable energy counterpart. Automobile industry, which acts as the biggest consumer of fossil fuel, have been developing certain approaches to address the problems of fossil fuel, in particular its limited resource. Out of all the probable alternatives, hydrogen as a renewable energy seems to acquire the most attention. Its higher heating value property compared to fossil fuel is one of the main considerations of why recent researchers have been focusing on hydrogen. Moreover, knowing the combustion reaction of hydrogen, water as a byproduct is much more favorable compared to carbon dioxide and other greenhouse gases produced from burning fossil fuel. In addition, hydrogen can be produced from water splitting mechanism, which is abundant in nature. So now the question is, why don't we just use hydrogen as it is? It is because hydrogen has much lower density in gas form compared to liquid. This means the same amount of weight of hydrogen needs to be stored in a much higher volume while in liquid form compared when in gas form. Basically, while hydrogen can produce twice the energy of natural gas or thrice the energy of petrol for the same weight, it requires around 3.5 times the volume of petrol for that weight. This is the main drawback of hydrogen gas as an alternative fuel, since the current automobile industry wants to stay with a similar concept of fuel tank, hence easier implementation rather than designing a new and way bigger size of the storage. How do we solve this? Metal Organic Framework, or usually called MOF, with its property of high surface area, is probably the one that has the highest potential among others. Sure, there are other options such as compressed hydrogen gas, liquid hydrogen, and the most recent one, which is hydride. However, they require either intensive operational energy or significant change on the infrastructure aspect. Also, even among the other sorbent systems, such as nanotube and activated carbon, and MOF has the best performance in terms of volumetric as well as gravimetric density. So, what is a MOF? MOF are crystalline solids that are constructed by the connection of metal ions, or clusters, through molecular bridges. In MOF, the surface area is directly proportional to the percentage of hydrogen absorbed. Thus, higher surface area means higher hydrogen absorbed to the framework. It is also relatively easy to synthesize since MOFs have already been researched and applied in many fields, such as carbon dioxide adsorption, catalysts, and many other applications. Another interesting thing about MOF is that, among others, MOFs possess the best flexibility in terms of properties adjustment, meaning that specific desired properties can be fine-tuned based on the materials of the MOF, making it versatile in almost all applications. This is also extended toward hydrogen storage consideration, and although current performances of the material is low compared to the target of the US Department of Energy, the optimization of MOF as hydrogen storage remains the best alternatives for hydrogen storage, and it has the potential to exceed the performance of even the current hydride metal. So how do we optimize MOF for hydrogen storage in automobile? There are three ways to do this.
Created using Powtoon.